All right. Good morning once again. I'll share. Okay.
Good morning. Please share your screen.
Okay, I'm doing that.
Recording in progress.
Okay. Can you see my screen now?
Yes, it's visible.
Okay. I'll quickly minimize this. All right. Thank you very much. Good morning once again. This is 6 minutes past 11 Nigerian time, and it's a pleasure to have me present my paper in this conference. My name is Caleb Onoja Kogu, and the name of the second author is Mr. Mabington DM. Mr. Marketing DM is actually my undergraduate project supervisor, and my topic is effect of palm kernel and olive oils on the preservation of Casady Folly tomato, Solanum lycopersicum, and we are from the Department of Botany, J.S. Taka University, Makurdi, Benue State, Nigeria. Thank you very much. Please, am I audible? And hope you can see my screen.
Yes, it's visible.
Okay. All right. Thank you very much. Yes, introduction. The essence of this work was to see how we can help farmers preserve tomato. We discovered that tomato is a major fruit, a major vegetable in Benue State, and it is planted every year. So, and we noticed high rate of spoilage due to lack of preservation and processing material to preserve these tomatoes. So what we sought out to do is to see how we can help farmers to preserve the tomato. So the materials and method, what we did, we went around to the major markets in Benue State, and we acquired fresh ripe tomato. And the oil we used, we purchased the oil from Wadata Market and all in Benue State. So the oil, we purchased two vegetable oils, namely palm kernel and olive oil from a supermarket in Benue State. And this oil, why we use the oil was because the oil can easily be processed by the farmers. So the treatment design, we divided the tomatoes into four groups, five groups, um, five tomatoes per group. So we first of all treated five tomatoes in the first group with palm kernel oil. We treated the second tomato in the second group with 5 mils of olive oil. Then the third group, we now did a mixture of 2.5 mils of olive and 2.5 mils of palm kernel. That was what we used in treating the other tomato in the third group. Then the fifth group, we left it untreated, so it was our control. So the measurement of physiochemical parameters. So we had to run physiochemical parameters on all the tomatoes. And the first thing was the weight percentage. So we, throughout the storage period, we were weighing the tomato to check the weight percentage loss. And also, we also did color analysis. So we used physical appearance to measure the color analysis, and we did post-harvest decay percentage. So the number of decaying tomatoes under storage were calculated using the formula. So as the storage period progresses, we're taking all these physiochemical parameters. So we also did shelf life. We This was computed on the basis of marketability and eating quality during storage period, with appearance of the fruit as guiding factor. We also did marketability. We checked for physical wounds, level of shrinking, smoothness, and glossiness of fruit with the aid of a formula as reported by Zaki et al. So we also did this, and we checked evaluation of microbial quality. That is, we had to check the bacteria and fungi that was responsible for the spoilage of tomato. And before we could do that, we had to prepare a media for it. So the media we used was maconke agar, saborite agar, destroyed agar, nutrient agar, and pecto water. So these were what we used in preparing the media. So preparation of tomato concentration. So what we did was to get 1 grams from the most infected tomato from the first group to the fourth group. So we collected the 1 gram from all the affected tomatoes, then we dissolved it in respective corresponding volumes of sterile distilled water in the various test tubes. Then we had to inoculate the sample. So after preparation of this media, we poured it into a sterile disposable petri dish and spread by swirling. So we are allowed to solidify. Then the media were inoculated with various dilutions of the affected part of the tomato, and they were incubated for between 1 to 3 days for possible growth. Then isolation of bacteria. So after the growth of the media, we now isolated. Sorry for the internet interruption. So we now, after collecting all the data, all we did was to analyze the data, and we used descriptive analysis and analysis of variance using SPSS to analyze our data. So the results, yes. So for the weight percentage, we discovered that as the storage period increases, the effect of palm kernel and olive oils on the weight of tomato before and after was not significantly different. This simply means that the tomato increased continuously lost weight as the storage period increases. And we discovered that the highest weight loss was observed on the treatment of olive oil on day 7, and the lowest weight loss was observed on control on day 3. So the oil could not prevent the tomato from losing its weight. Yes, so this is the table showing the weight loss of the tomato. You could discover that as the storage period increases, the tomato progressively lost weight, and the oil could not preserve the tomato. So for firmness, we also discovered that the tomato always the firmness of the tomato also decreased as the storage period increases. This simply means that the oil still could not have effect on the firmness of the tomato. So from the table, you could see how this is a scale, and this is for palm kernel oil, this for olive oil, this for palm kernel and olive oil, and this for control. So you could see that as the days progresses, the firmness of the tomato was always reducing. And the color as well, we discovered that the color progressively changed from pink light, red light as the storage period increases. So the more the tomato were in storage, the more the color of the tomato were changing from pink light to red light. So from pink light to red light. Yes, for post-harvest decay percentage. And the post-harvest decay percentage over the storage period showed that the post-harvest decay of fruit increased as the storage period increased. So post-harvest decay percentage of Casady Folly showed that treated fruit on day 8 showed the highest number of decays, and control showed the lowest number of decay. So the oil also had no effect on the decay of the tomato fruit during storage. So for shelf life, the shelf life of Casady Folly over the storage period showed that the shelf life of the food decreased as the storage period increased. As shown in the table, the oil had no effect on the shelf life either. So for marketability, we also discovered that the marketability decreased. That is, the tomato were not marketable as the storage period increased. So for the microbial count, the effect of palm kernel and olive oil on the microbial count of Casady Folly over the storage period showed that the effect of the oils on bacteria on McConkey agar and nitrate agar were significant. That simply means the oil was able to reduce the the growth of bacteria on McConkey and nutrient agar. And the effect of the oil on fungi on saboraid agar was not significant. That simply means that the oil could not inhibit the growth of fungi on the saboraid destrate agar. On microbial count on McConkey and nutrient agar, there was significant difference in the growth of bacteria when palm kernel and olive and when palm kernel and a combination of palm kernel with olive oils compared to control. So the oils was able to inhibit the growth of bacteria on the McConkey agar. However, it could not inhibit the growth of fungi on the Saboroidostro agar. So we're able to isolate some bacteria. So for bacterial isolate, we discovered that Staphylococcus species, Klebsiella species, Escherichia coli, and Salmonella species and Shigella species were among the bacteria that were associated with the spoilage of tomato. And from the percentage, we discovered that Klebsiella species had the highest percentage. So Klebsiella species was the highest bacteria that was isolated from the spoilage of tomato. And also from the fungi, we were also able to isolate some fungi that were associated to the spoilage of tomato. We discovered that Aspergillus species, Mucus species, Saccharomyces, and Rhizopus were isolated. And the highest fungi is Aspergillus species. So these are the pictures of the fungi that were isolated. These pictures were taken with the help of a microscope. So, conclusion, we discovered that at the end of the storage period, at the end of the research, the oil, that is the palm kernel and olive oil, could not um, help in increasing the shelf life of tomato. We discovered that if the oils were supposed to be used for preserving the tomatoes are supposed to be used as quick as possible or sold as quick as possible because the oil could not inhibit the oil could not inhibit the fungi and the bacteria that were associated with the spoilage of tomato. Neither could the oil increase the shelf life, the marketability, the post-harvest decay. The oil had no effect on the preservation of the tomato. So we brought out two recommendations, and we recommended that palm kernel and olive oil should not be used in the preservation of Casady Folly tomato. And also we recommended that Casady Folly preserved with palm kernel and olive oil should be sold as soon as possible, as the quality and marketability of the fruit decreased with time. So these were the recommendations we brought out at the end of our research. So thank you very much for listening, and the floor is now open for questions. Thank you very much.
Thank you, Dr. Helen Anoja Akogbu. Is there any questions or recommendations?